Do you have your copy of the worksheet and the lecture notes?
I know I have a worksheet somewhere. I don't know what the notes.
The notes. Yeah, it's a packet that has intermolecular forces in the title. Now this is the first page. Alright, so we'll continue with intermolecular forces. We'll answer some of the questions in the worksheet as well. So what do you remember about the intermolecular forces?
There's like, what, 3 types of it?
There are 3 types. Okay, what are the 3 types of intermolecular forces, Megan?
London and dipole-dipole. Oh yeah, the H bond.
Okay, so London dispersion forces, dipole-dipole, and the H bond. And then last time we also looked into the relative strength of these forces. Which one is the strongest?
H1.
H bond is the strongest, followed by
Dipole.
dipole-dipole and
Dispersion.
London dispersion forces. Okay. And then in order to identify the type of intermolecular force, we can look at the components of our compound, like whether the compound is polar or non-polar, or whether it contains hydrogen bonded to elements which are more electronegative, like fluorine, nitrogen, and oxygen. So NOF, and if you are looking at the periodic table, like if you have a periodic table, okay, let's see here. You should have a periodic table in the book. And we're just looking at 3 elements on the right side, color yellow, in this periodic table, NOF. So only 3. If hydrogen is bonded to N, to O, or to F, that's going to be an H bond. And we've learned that an H bond is a stronger version of the dipole-dipole attraction. It's dipole-dipole because you have hydrogen bonded to a more electronegative element, and so dipoles are produced. But because nitrogen, oxygen, and fluorine are very electronegative, they will tend to have much bigger share of that electron cloud, distorting the electron cloud. So partial negative on the end where you have NO or F, and then partial positive for hydrogen in the bond. This hydrogen bond is only present when hydrogen is bonded to NO or F. So if you have a carbon to nitrogen, carbon to oxygen, or carbon to fluorine, that is not a hydrogen bond. Okay? If you have hydrogen to carbon, hydrogen is bonded to carbon. Carbon is not as electronegative as nitrogen, oxygen, or fluorine. So a C2H bond is not an H bond. Are we good with that? All right. So we're still in the same chapter. Chapter 12 for this one. Last time we also looked into the comparison between the intermolecular and intramolecular forces. So what is the difference between intermolecular and intramolecular forces? Like, what do we mean if we say intermolecular? And how is it different from intramolecular? Decker?
Intermolecular is chemical bonds within a molecule, and intermolecular is a force that occurs between molecules.
Okay, that's correct. You have, for example, if you have a cup of water, you have many water molecules in that cup of water. So these water molecules interact with each other. They are held together by a force, and that force is H bond. So that force holding the water molecules together is an intermolecular force. Intermolecular meaning between two molecules. When you say intramolecular, it's within the molecule. Like in H2O, you have a bond between oxygen and hydrogen. So that is an intramolecular force. The intermolecular forces in or between molecules give rise to the difference in boiling point or melting point or some other characteristics. So if we look at the first page of our lecture notes for intermolecular forces, relative boiling points, here, down here, dipole-dipole interactions and hydrogen bonding. Which one do you think will have a higher boiling point? Compounds with dipole-dipole attraction or compounds with hydrogen bonds? Higher boiling point. So if you have molecules, okay, so molecules, for example, this is, all right. So you have H2O, another H2O, and then some more H2Os around it. And then they are held together by H bond. But you have another set of, or another sample of compounds. That's not H2O, for example, let's say HCl. And which one? HCl is dipole-dipole. Okay, let me write it down. HCl is dipole-dipole. You have dipole-dipole attraction. And H2O has H bond. Alright? So we compare these two. Again, which bond is stronger? Is it H bond or the dipole-dipole attraction? H bond is stronger. Now, because H bond is a stronger attraction, it will hold these water molecules together. As a result, the boiling point will be higher. So generally, for H bond, you compare that to dipole-dipole. Dipole-dipole is weaker, so you need a certain amount of heat applied to the sample and then boil it. When you boil it, that means that some of your molecules will start turning from liquid to the gas phase. Remember, phase changes. And then if you have an H bond, because the bond is stronger, you will need a higher amount of energy. So you'll have to supply more amount of energy to your sample so that the liquid phase of that sample will be converted into gas. So for boiling point, whenever you have dipole-dipole and hydrogen bond will cause a molecule to have a higher boiling point. What is boiling point, by the way?
Changes where a liquid boils.
Okay, temperature when the liquid
Boils.
boils or
Turns into a gas.
Okay, temperature needed for the liquid to turn into a gas. For example, for water at sea level, the boiling point is 100 degrees Celsius. And that's going to be, the value would be different for different substances. Like if you have an ionic compound, the boiling point would be higher than a covalent compound. Any questions so far? So let's have some more examples in here. Please refer to your worksheet. So we're done with number 1 question in this worksheet. If you remember, all covalent compounds have the dispersion forces or the London dispersion forces, but not all of them have H-bond and dipole-dipole attraction. So, given the formula or the structure of a compound, we can determine what intermolecular forces of attractions are present. Now, in number 2 problem, list the dominant type of IMF. What does IMF stand for? Intermolecular forces. So list the dominant type of intermolecular forces for the pure substances. Then rank the strength of each compound based on IMFs within the samples. For the ranking, you'll have to write numbers on the last column in this chart, and the strongest will be assigned number 1. If it's in between, that's going to be number 2, and the weakest would be number 3. So we have 3 substances: HBr, hydrobromic acid, oxygen molecule or O2, and CH3OH is called methanol. Let me write down. Right here, CH3OH. Now this one is an organic compound. This is an alcohol which has only 1 carbon atom. And the structure, I need a volunteer to draw the structure of methanol on the board. Decker?
Maybe put this down there.
You may just draw it right here. It's important to draw the structure because we want to see the covalent bond. We want to see which atoms are bonded to which atom, like if O is bonded to H, because that's gonna matter how you will classify your molecule as either having an H bond or having just a dipole-dipole attraction. Because remember, the H bond is H2O, H2N, or H2F. Now, if you have if it says CH3OH, but then O is not bonded to H, then it's not an H bond. If you have C to O, and then C to H, but no O to H, then it's not H bond. If you have an O to H, then that is H bond. Okay, that's looking good. You only need to add lone pairs on oxygen.
You wouldn't have, would you put 6 of them on there, or would you put 4?
4, because you have 2 bonds already.
That's what I thought.
Yeah, so you need 4 more to complete the octet. Okay, good job. So we have methanol. Another name for this one is methyl alcohol. Meth refers to the prefix meth refers to the CH3 here, methyl. So this is meth methanol, OL for alcohol. Hi, Tim. Yeah. Welcome. We're just talking about IMFs, and Becker has just finished drawing the structure of methanol. So short background on naming of organic compounds. If you say like the name starts with meth, it means that it has one carbon atom. Like here, that's a methyl group. Now, OL, the name ending OL is for alcohols. So whenever you see a name of a compound, an organic compound that has that ends with OL, that's an alcohol, like ethanol, propanol, butanol, and many others. Well, some of them, like the more complicated ones, you can have like an OL and some other name endings that they add in there. Okay, so here we have C2O to H. Now we're comparing that to HBr and O2. And Tim, we are working on number 2 in the worksheet. So HBr, O2, and then CH3OH. Let me erase this. 2 molecules in here. Now I need a volunteer to draw the structure of HBr on the board. Aside from Decker.
I was hesitating. I was like, oh, here we go.
Yeah, I'm gonna need another volunteer. We'll give a chance to
Break out of the hat.
Megan. Would you like to draw the structure of HBr on the board? No.
It's just the hydrogen with the bromine.
Yeah, it's
Yes,
hydrogen with the
And it
bromine.
has 6 dots.
Yes.
Oh, here. It's like, okay. All right. And then when Megan is done, I'm gonna need another volunteer to do O2. I don't think O2 is a complicated. It's a molecule,
Just
right?
oxygen with oxygen.
Yeah, for O2, you're gonna have a double bond. Good job. Okay, we have the HBr. Let's was O2.
I'll do it, but.
Tim,
There you go.
making up for the lost time.
Yeah.
Yeah, that's why we need you here, Tim.
You need 10 of those ones.
Okay, so it's gonna be, yeah, double bond.
And then you
That is correct. Thank you. So we have, yeah, 2, 4, 6, 8, 2, 4, 6, 8, and then we have our HBr. So now we have the structures. Next, we'll go over the questions that will help us determine what intermolecular forces are present. First question. Is the molecule, or no, is hydrogen bonded to oxygen, nitrogen, or fluorine? Do you see anything like that in these 3?
There's a
Compounds?
hydrogen bonded to oxygen and methanol.
Okay, hydrogen to oxygen and methanol. And because we have hydrogen to oxygen and methanol, what is the name of this IMF?
H1.
H-bond, correct. Okay, so we'll label this as H-bond. And this, the H-bond is right here. Now, don't be confused with the H-bond and the covalent bond. Sorry. the H bond is not, this is not the H bond. This is the reason why there is an H bond. The H bond is between this molecule, and if you say you have another CH3 OH. Okay. Let's say you have two or maybe more of them in a container, and then you're gonna have, let's say this is partial positive, this is partial negative, this is partial negative, and this is partial positive. So where is the H bond? The H bond is between the partial negative. I'll use a different color. Green, partial negative, and the partial positive. Now I'm using broken lines because that is not a covalent bond. It's just a force holding these two together. So it's between the oxygen and the hydrogen, but not the oxygen and hydrogen in the same molecule. It's the oxygen of one molecule and the hydrogen of the neighboring molecule. And that's where you have the H bond. Any questions on that? So we have eliminated methanol. Okay, so we have H bond for methanol. Next question. Is the molecule polar, or which molecule is polar? We have two molecules left, HBr and O2. Which one is polar? How do we know whether a bond is polar or non-polar? Do you remember electronegativity? Electronegativity.
Is it HBr?
It's HBr, correct. So we base on the electronegativity. You can either use the electronegativity values in the book, or you can simply look at the location of the atoms or the elements in the periodic table. So look at this periodic table. You have H, then Br on the right side, and you're comparing that to an oxygen molecule. That's O. So you have two oxygen atoms, because these are the same. We have the same atoms for O2, two oxygen atoms. If you're going to subtract their electronegativity values, what will you get? Let's say for zero, because you have the same number. For example, I would say 3.5. Yeah, 3.5 minus 3.5. So based on the values, the electronegativity values, what you do is you subtract their electronegativities. If you get 0, then that is nonpolar. If you get if the difference is bigger than 0, let's say from 0.1 to 0.4, that is slightly polar. If you have 0.5 to 1.9, that is very polar. Now, because there's only one bond that we're considering, so that's going to be easy. But if you have like 2, 3, or 4 bonds, or maybe more bonds, that's when you look at the geometry of the molecule to know whether the molecule is polar or nonpolar. And okay, HBr, H is here, Br is on the other side. For example, we don't know the values. You don't have the table, and we don't memorize electronegativity values. I just remember some of them because I talk about them all the time. But you don't need to memorize the values. So, you don't have the values, but you have a periodic table. Just the symbols, no numbers, or maybe just atomic numbers. So, the trend can be used to do that. Okay, what is the trend in electronegativity?
Increasing from left to right and decreasing from top to bottom.
Correct. Increasing left to right, so hydrogen is on the left, and bromine is in the far right, although it is in the fourth row or fourth period, but it's still on the right side. So now we know that bromine is more electronegative than hydrogen. Now because bromine is more electronegative than hydrogen, bromine will be stronger than hydrogen in terms of pulling the electron clouds. Remember, these two elements are sharing electrons. So for example, this small one, the white one is hydrogen, the black one is bromine. So you have an electron cloud. The electron cloud is the covalent bond between the two. Since bromine is more electronegative, it is stronger. So bromine will pull this electron cloud towards itself. But then it will not break the bond because the bond is covalent. So what will happen is the electron cloud, instead of equal sharing of the electrons, what will happen is it will be distorted towards bromine. So bromine will have a bigger share of that electron cloud, making bromine a partial negative, and then hydrogen will be partial positive. Does that make sense? Okay. So electronegativity or electronegativity values, calculate for the electronegativity difference, or simply look at their location in the periodic table. Now, going back to my question, which compound is polar? HBr. So let's label that. And because HBr is polar, what intermolecular force of attraction is present? Dipole-dipole, correct. For polar molecules, it's gonna be dipole-dipole attraction. We're left with O2. Is O2 polar or non-polar? Non-polar. Non-polar because we have same atoms, so it's going to be equal sharing of electrons. And I heard someone say London dispersion forces. So you may write this down in your worksheet. Second column in number 2. So HBr is dipole-dipole, O2 is London dispersion forces, and methanol H bond. For the relative strength, okay, 1 for the strongest, 2 in between, and 3 weakest. Which one here would be our number 1? H bond. Number 2, dipole-dipole, and number 3, London dispersion. Any questions so far? None? Let's continue. Question number 3, circle all the species below that can form a hydrogen bond in its pure form. Explain why the other species couldn't hydrogen bond. Now, what I would like you to do is to draw the structures of these molecules.
I'm going to say
In your notebook,
the fourth one, the H bond.
the fourth one,
It's either the fourth one or the fifth one because they almost have oxygen. So.
1, 2, 3, 4, 5. Okay, so Decker says the fourth one has H bond.
It's either the fourth
Is,
with it.
is that what you were saying? The fourth one has H bond?
Yeah, it's either one of them, because they're the only ones that have oxygen. The first three can't even H1s, they have oxygen. Oh, wait, no, the second one goes with nitrogen, never mind.
Yeah, you are right. Okay. So, and so 2 answers for number 3.
Wait a minute,
Nitrogen, what else?
fluorine, oxygen, nitrogen. Wait a second. Oh, all three of them?
All 3 of them. Just number 4, number 2, 2 and 4. Okay, so you can check that by drawing the structure. We don't have enough space in the worksheet for the drawing, so you may draw the structure in your notebook. Like when you get used to this already, actually you don't have to draw the structure on the paper because you can mentally determine which bond or which compound has H bond or just dipole-dipole or London dispersion. But for a start, it's always good to draw the structures. Let me erase this so we'll have some more room for the structures. Now for bigger molecules, whenever you draw their structures, just follow their arrangement. Like for example, CH3 and H2. So you're going to have the C bonded to 3 hydrogen atoms, and then N is bonded to 2 hydrogen atoms. The first one, C2H6, the C's, the 2 carbon atoms should be bonded together. And then you just divide that, distribute your H. So that's 6, so meaning each carbon will have 3. For the last one, CH3OCH3, it means that the oxygen atom is between the 2 carbons. And then each carbon will have 3 hydrogen.
That one can't H1. Figured it out.
Yeah, because oxygen is bonded to
Carbon.
carbon, not hydrogen.
Can't. The second, the fourth one can't though.
The fifth one?
Nope.
And then whenever you're ready, I'm gonna need some volunteers to draw the structures. Which structure are you going to?
CH3, CH2, CH2OH.
Okay.
Get the carbon out of the way.
And you may draw your structure over there. So, I'll lay this up so you'll have more room for your drawing.
Bring in a notebook for this one.
The third row. Here. This is my good
Such a mark.
marker.
I'll send you another one.
Megan, which one are you going to do?
KCl.
KCl. Okay. And that's ionics.
Yeah.
May I see your notebook? It should be K plus. And then this line here should be dots. Because all the electrons are in Cl. And you put K plus and then Cl, put that in brackets and a plus sign.
Okay.
All right. Good job. So that's the fourth one. How many carbon atoms are there? 1, 2, 3. So that's propanol. Yes, Flynn?
C2H6.
Okay,
Did I show you?
sure. That's correct. good.
You edit moves.
Flip, you might wanna draw.
Sounds about right. Oh, sorry. I don't see that. Fifth grade songs, and then I lose.
And it's actually a good application of drawing structures of molecules, Lewis structures. Yeah. KCl is ionic. So like the first one that you can eliminate in this group is KCl because it's ionic. And whenever it's ionic, there's no H bond. Okay, so we have how many? 3. 2 more.
I'll do CH3OCH3.
Who will do CH3 or CH3?
I'll do it.
Leanne or Leanne? Okay.
You just put a C and a C and an O in the middle and then 3 H's around the C's.
Yes, and if you put lone pairs in there.
I got you. And this
So
one-
Leanne is doing the last one. The name of the last one, the
There's one more.
CH3OCH3 is dimethyl ether.
There's one more.
It's ETHER.
CH3NH2, Flynn.
Yeah.
Yeah, I'm working on that one.
CH3NH2, that compound, these are, say, all of this except the KCl are organic compounds. NH3NH, CH3NH2 is an amine.
7, 12, 14.
Some people say amine. And that's related to, or that's, the structure is similar to amino acids.
Just 4 plus 3.
They have NH2.
Is the total number of valence electrons for CH3 and H2, is it 14?
Let's see.
4 plus 3 is 7, and 5 plus 7 is 12, plus 2 more is 14.
Yeah, 4, 7, 14, that's right. 14 electrons. Alright, so CH3OCH3 is correct. Last one.
Oh, I think that is right. Type 5.
Okay, Flynn wants to do it again. Are you sure, Tim, you don't want to do it?
Wait, Tim, didn't you do one?
No.
Oh, I'll do it again.
I think I have it.
Okay, Flynn will do it again. So we'll, here in a little bit, Decker can participate twice too.
You want to try to do it over there?
Left side.
Okay.
And it's correct. Good job. So, let's go back to the question. Circle all of the species below that can form H bond. How many compounds in this set can form H bond?
2
Just 2. And what are they?
CH3NH2 and CH3CH2 CH2OH.
Yes. So this one right here can form H bond. And it says explain. Let me say this one. Green. Any questions? Explain why the other species couldn't hydrogen bond.
Well, KCl doesn't have a hydrogen, it's an ionic compound.
KCl is ionic compound, correct?
CH2H6 doesn't have any oxygen, nitrogen, or chlorine in it.
Correct.
And CH3, OCH3, the oxygen's bonded to 2 carbons, so there's no hydrogen oxygen bond.
All right, good job. Let's have the next one. Number 4. We have 3 compounds. Rank the following compounds from weakest intermolecular forces to strongest, and then justify your answers. Now, what I would like you to do for number 4 is to put because you just have to rank this, put this sign. What's that? It's less than sign. Like, or, let's see. Yeah. Now, before you can do that, of course, you need to identify what intermolecular forces of attraction are present in these compounds. What is the IMF in I2?
London dispersion.
London dispersion, correct. IMF in H2S,
Dipole.
dipole-dipole. IMF in H2O,
H-bond.
H-bond. So we're going to put a less than, because it says from weakest to strongest. So meaning the force in I2 is less than H2S, and H2S is less than H2O. Or H2O is greater than H2S, H2S is greater than I2. Number 5, which of the following will have the highest melting point? Again, we will use the IMF to determine which one has the highest melting point. The answer is D, that is correct. Why?
Hydrogen bond.
Hydrogen bond. D is the only one which is the hydrogen bond, and we know that hydrogen bond is the strongest of the 3 intermolecular forces. Number 6. Circle all the compounds which would be expected to form intermolecular hydrogen bonds in the liquid state.
Nope.
So again, if you are not sure, draw the structure. We have the structure of CH3O, CH3 on the board.
No. Yep. No.
Okay, let me erase some of this. I will leave this one because that's included in this question.
CD now. CDF. I use molecule as an option, but
All right. So 6 molecules. Which compounds can form intermolecular H bond?
C, D, and F.
C, D, and F. Do you all agree? Correct. 3 molecules or 3 compounds.
Silence.
Letter C is HF, So hydrogen bonded to fluorine. Yes. Letter D has an OH bond. The structure for letter D is CH3. 1, 2, 3. C double bond O, single bond there. And we have here O to H bond for letter D. In letter F. Number 8. We'll skip number 7 for now
Say crystals.
because we have not discussed crystals yet. Okay, number 8. For the table below and on the next page, specify the predominant intermolecular force involved for each substance in the space immediately following the substance. Then in the last column, indicate which member of the pair you would expect to have higher boiling point. So our pairs would be letter A, we are comparing HCl gas and I2. Now, it is specified in here that it's a gas because it has to be in the pure form. So, because if you add water, you have the factor that's H2O in there, and H2O has H bond. So like this is just HCl, no water, just a pure HCl gas. You compare that with I2. What is a predominant intermolecular force in HCl? What is in I2? The substance with a higher boiling point will be the substance with a stronger IMF. Okay? So you may do this for 5 points. A, B, C, D, E, F, G, H, I. And we have 2 minutes left. So if you don't finish this one, you may turn in your work tomorrow. Let me know if you have some questions. And tomorrow we'll discuss crystals, metallic, ionic, covalent, or the molecular crystals. To help you out with this, you might want to look at this chart on the second page because it has some definitions. Alright, so that's gonna be all for today. Like the FE and KR, we'll have to discuss that tomorrow.